Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about ozonolysis reaction. This is in accordance with NEP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime, and help to learn others. So basically, this is the syllabus for Major 2 and Minor 2 paper, Fundamentals of Organic Chemistry. So today we will be talking about ozonolysis reaction. So this is the formula of ozone O3. So O3, the ozone, is a triatomic form of atomic oxygen and it is a pale blue gas. So usually this ozone O3 breaks down C double bond C and C triple bond C to afford the carbonyl compounds. So here we can see the structure of O3. O double bond O plus, then single bond O minus. And this will undergo resonance. So when this O minus will come back, this double bond O will break on this oxygen. So as a result, again you get the same structure. So usually what happens when you take the alkene and you react with ozone O3, you will get ozonide. And we will see now how this ozonide is formed. And further, if you react with dimethyl sulfide, you will end up with, so this ozonide will break, it will give rise to two equivalent of acetaldehyde. So here is the mechanism, how this ozonide is formed. And this is the alkene and this is the structure of ozone. So that you have to write in this fashion. So this alkene double bond will act as nucleophile. So this double bond will attack to this oxygen. So this double bond will break on this O plus and this O minus will attack to this carbon. So here this is called the 3 plus 2 cycloaddition reaction or 1,3 dipolar addition reaction. So as a result you will end up with this mole ozonide. And again this will undergo simultaneous bond making and bond breaking. So this bond will move here and this O double single bond will break on oxygen and this oxygen lone pair will come here. As a result you end up with these two species. And again these two species will undergo 3 plus 2 cycloaddition reaction. So as a result this oxygen lone pair will attack to this carbon and this CO double bond will break on this O plus and O minus will attack to this carbon. So as a result you end up with this ozonide. So once you react the alkene with ozone you will end up with ozonide, but the thing is if you react further with dimethyl sulfide or hydrogen peroxide or sodium borohydride you will end up with a different product. So in presence of dimethyl sulfide you will end up with acetaldehyde, aldehyde. And if you take hydrogen peroxide it will undergo oxidative workup, you will end up with acetic acid. And if you react with sodium borohydride you will end up with alcohol. So the reaction of alkene with ozone to give rise to the product of C double bond C bond cleavage is called ozonolysis. So basically what happens here, this alkene will undergo cleavage giving rise to different products. So the ozonide undergo reductive workup to give carbonyl compounds mainly. So in presence of dimethyl sulfide, what happens? So this is the structure of dimethyl sulfide. So sulfur lone pair will attack this oxygen and O single bond O will move here and this bond will cleave and it will move here and this CO bond will cleave on oxygen. So as a result you end up with the two equivalent of acetaldehyde and dimethyl sulfoxide. Similarly in presence of zinc dust and water, again this is a reductive workup. Zinc lone pair will attack this oxygen and this bond will move here and this bond will move here and this bond will break on this oxygen. So this movement of arrows you need to practice. So as a result you end up with two equivalent of acetaldehyde and zinc oxide. So generally triphenyl phosphine, dimethyl sulfide and zinc or mercury is used for reductive workup to give rise to triphenyl phosphine oxide, dimethyl sulfoxide, DMSO and zinc oxide. Similarly, we can go for the oxidative workup of ozonide in presence of hydrogen peroxide and water. Once you get this ozonide, this ozonide decomposes upon warming. So this will decompose when this oxygen lone pair will come here and this bond will move here and this bond will break on this oxygen. So we end up with this acetaldehyde and this dipolar compound. So hydrogen peroxide, oxygen lone pair will attack to the carbonyl carbon of acetaldehyde, and CO double bond will break on this oxygen. So as a result, you get CHO minus and this OH plus, and this O minus will take this proton. So as a result, you end up with this hydroxy and peroxide compound. And again, what happens in presence of water? So oxygen lone pair will take this proton, and this bond will move here, and it will kick out OH as OH minus. So you end up with the product acetic acid. Similarly, this uh, this species, water will attack. So oxygen lone pair will attack to this carbon, and this CO double bond will break on this O plus. So as a result, you end up with this species. When this O minus will take this proton, and this OH bond will break on this O plus. So as a result, you end up with this species. Again, water takes this proton, and this bond will cleave here, and it will kick out OH as OH minus. So we end up with carboxylic acid. Similarly, reductive work up with sodium borohydride. So this ozonide is unstable, and usually it will break, giving rise to acetaldehyde and this species. What happens? Sodium borohydride. So hydride transfer will takes place to this carbon, and this CO double bond will break on this oxygen. So as a result, you end up with this oxyanion, and this oxyanion will take the proton from alcohol. So as a result, you end up with the alcohol. So here are some problems for ozonolysis. So suppose you take this cyclohexene and you react with ozone. What will be the product? And you treat that with zinc and acetic acid. What will be the product? Similarly, you take this simple alkene in presence of ozone and triphenyl phosphine. You need to write down what are the products. Similarly, this cyclopentene derivative. So in presence of ozone and sodium borohydride, what will be the product? So please subscribe to our channel Chemistry Live UGPG. This is the channel for class 11th and 12th students, Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you all for learning.